So let's tackle this next problem together. So we're moving into the world of analytical chemistry and biotechnology by plotting a standard curve for a Bradford assay. So the question asks, the Bradford assay is a colorimetric assay used to measure protein concentration. The protein concentration is exhibited by a color change of a solution from clear to blue. Using the data provided by the technician below, plot a standard curve on the provided grid. Ensure you label your axes, include units, and draw a line of best fit. And so then it gives us concentration and the average absorbance at 595 nanometers. So this is a fundamental skill. The word assay simply means test. So let's just remember that. And this is a colorimetric assay, so it's going to change color as as there's more protein in our concentration. So the darker the blue of our solution, it's going to mean that there is more protein in that solution. So in any experiment, we have an independent variable, the thing that we control, and a dependent variable, what we measure. So our x-axis, so let's go ahead, let's draw a thick line. Let's draw an x-axis here. And so this is going to be our, the thing that we are measuring. And so this is going to be bovine serum albumin, or BSA. And so we'll write over here our BSA concentration. And the units are going to be in micrograms per milliliter. And then for the y-axis, this will be our average absorbance. This is the blueness of the machine that's going to detect as the protein reacts. So let's go ahead and draw our y-axis. It's going to connect these two together. All right, so, and then we have to label this, right? So this is going to be average absorbance at 595 nanometers. All right, so that is setting that up. So now let's talk about our data table. So it looks like concentration is going to go from 0.0 to about 1500 micrograms per milliliter. And you'll want to choose a scale where each major grid line represents something easy to count. So we'll just do like 250 units. So if this is 0, we'll say this is 250, 500, 750, 1000, 1250, and then we'll do 1500, and then we'll take it out a little bit more, and so we'll do 1750 there. And then for our absorbance, it's going to go up. So it goes from 0.0 to about 2.3. So we'll make each major grid line be kind of worth 0.5. So let's do 0.5. We'll do 1.0. So we're going up by 0.5 each time. So 1.5, 2.0, and then we'll do 3.0 up here. And then we just need to come in and plot our points. So the first one is going to be 0 and 0, so we'll just kind of put that down here. So that's our blank. The second one is going to be at 250. We get a measurement of 0.4, so we'll put a dot there. At 500, we get a measurement of 0.8, so we'll put a dot here. At 1,000, we get a measurement of 1.5. That looks like it's about right. At 1250, we get 1.9. So we'll come over here. And then at 1500, we get about 2.3. So now that we've plotted our points, now we have to draw a line of best fit. So let's come back here. So it says draw a line of best fit. This doesn't necessarily need to touch every single point perfectly. Instead, it's going to be a straight line that averages out the data to show an overall trend. So what we will do is we'll place a line here where some of the points are below and some are above that line. And so this should be ideally in a perfect world. So once this line is drawn, you have kind of like a decoder ring. If you have an unknown protein sample and the machine tells you it's an absorbance of 1.0, so maybe we'll say it's like right there, and the machine tells you it's an absorbance of 1.0, you can find that on the y-axis, move the line over and see what the concentration is going to be. So, it would be, let's say, 500 micrograms per milliliter. All right. That's how to plot a standard curve using some data points that they give you.